know that I stopped here last time, okay, and this is what our final equation in terms of concentration. Just to be aware that you can also use it in terms of pressure if you have, if you have gas phase and you have a pressure in your data. So you can say PA equal to or CA equal to, okay, so CA is equal to PA over RT, right? Okay, you can also use it for CA naught, right? Okay, so it means you can replace CA naught and you can replace CAE, right? Okay, so all these can be CA naught. It will be what? PA naught here. CAE it will be PAE over RT. Okay. Now these are you can change your equation positions in terms of pressure if you want. Okay. Now let's see if we now we are done with the derivations of this chapter. We know more derivations. I will go and solve some questions, right? Okay. So this is what we are going to do now. Okay, we are going to solve some questions. Okay. I will go and look at the questions of the half-life, okay, because these are the questions that we were there, okay, and we did the derivations, but we did not solve the questions. So this is what we have, okay, example number 10, because we did everything else, right, okay. Now, example number 10, I have data of P naught and T half. You could see that. Okay, now the question is giving me the one reactant. I only have one reactant. So the equation is A to products, right? Okay, or A of A, I don't know, but it is only one reactant. Okay, so this is what I have. I also have the temperature. Okay, and I want we are I'm told that we are assuming constant volume. We want to determine the order of reaction. We want to determine the rate constant, but the units must be moles, liters, and minute. Noticing that the time is in seconds and the pressure is in millimeter mercury. Okay, so what do we do? Of course, we have to, as I said, we have always to derive all necessary equations. Okay, so when we want to derive, we cannot derive as we did previously. What do I mean? Previously, I derived the equation for half-life. Okay, so is it not good for this for this case? Okay, let's see. Is it not good? Okay, let's see. What is it we have derived? As I said, previously I derived the equation. So is it wrong? No, it's not wrong. But is it going to be the same equation that I should be using here? Mostly, but there is what I mean. The starting point for that is not the same. Okay, what do I mean by that? See here, when I started the equation, I started. See here, this was my sorry. Okay, this was my case, right? Okay, see here, when I started the derivation, I said A of A plus B of B. That was my reaction. So I started by KACA to the alpha, CB to the beta. You could see that, okay? And then got the relation between CA and CB, whatever. But in the case that I have now, it is not the same. I don't have A and B. I only have A. So am I going to start with CA and CB to the CA to the power alpha, CB to the power beta? No, I'm not going to do that. I'm simply going to start with what? Let me just show you something. Okay, sorry. I will just copy something. Just okay. Okay, I will just copy something and that's it. Okay, so this is my this is what I did previously. Okay, now what is it we will do now? Am I going to do the same? I said no, I cannot do the same. Why? Because I don't have A and B. So what is it I will do? I will start with the case that I have. I will write my equation in terms of the reactant that I have. Okay, let me just go back to the example. Okay, so I will write my equation here. I will say minus RA is equal to minus 1 over V d in A by dt. It is equal to K or Ka to Ca to power of alpha n whatever I will say n. Fine. Okay. Then of course I will have to show that for constant volume, right? Okay. This is constant volume given, right? Okay, given constant volume. Okay, and I will assume what? assume constant, okay, T, okay, at 1030 Kelvin. Okay, this is what we have. Okay, now I will, as I said, I'm going to, you have to show me, sorry, okay, let's leave it that. Okay, you have to show me that this is equal to what? As usual, يعني. You have to show me that it is equal to what? Minus dCA by dt, right? Okay, and you have to show all the derivation steps, right? Okay, and I have repeated that so many times, يعني. Okay, so please always show the derivation steps, okay? Because if you don't show, sorry, if you don't show the derivation steps, you will lose marks, okay? So this is it. Okay, now we got it. Then what is it we will do? Of course, we are going to say it is, this is what? Minus dCA by dt. Okay, it is equal to kCA to the n. Okay, kCA to the n. Okay, don't worry. Okay, it is equal to kCA to the n. Then I am ready to what? I'm ready to integrate. Okay, so how do we integrate? As we did previously, and the integration, sorry. Okay, I don't want to waste time. So KCN, K to CN to the N. Okay, so what is it will happen? We'll have to follow the steps, these steps. Okay, now in these steps, I have what? I have a K prime. It will only K. So we did that division previously. See here, this is only what? K only, right? Okay, not K prime. So it is just K or KA, but not K prime. Okay, so this is what I have. Then what is it I will have to do? Of course, I will have to change what? I will have to change the concentration to pressure. So we have what? We also have done that previously. Okay, now just to remind you, what is it we have done previously? We have changed the equation into a pressure. Why? Because I have data in terms of pressure. Okay, so why do I يعني, what is the reason that I am changing? Only because I have data in terms of pressure. If I don't have data in terms of pressure, I will have what? I don't have to change. So this is my equation, and I will just copy it for you to see later on that you need to do the derivation, the whole derivation, right? Okay, so this is what we have here, and I'm copying. Again, reminding you, in this derivation, it is only k. There is no k prime. This is only what? K, no k prime. Okay, so just k. Fine. Okay, so let's see here now. What do we want to do? We want to apply this equation and we want to calculate. Okay, let's have our data back. Okay, so our data, we'll have them. Okay, so where are the data? We have them. Okay, I will just copy it again. Okay, so these are the data, right? Okay, so let's use the equation. Okay, so the equation is telling me to plot. Plot what? Log T half versus log PA naught, right? Okay, it means I will have to calculate. Okay, so I will have to calculate, okay, log PA naught and also log T half, right? Okay, so I will write it here. So that should be log PA naught, and this should be also log T half. Okay, so for those who are interested in calculating, you can calculate now, okay, and you can give the values here, okay. Otherwise, I'll just give you the linear regression, okay, and it's up to you if you want to do it at home or not, okay, it's up to you, okay. So if you want to do, fine, otherwise I will just give you the linear regression, okay. So I'm not going to wait long actually, because I don't want to waste time. Yes, you are going to calculate. Okay, R squared is 0.986. Okay, let me just check my R squared. Okay, I got 0.9864, yes, 0.9. Okay, 0.9864, yes. and the slope it is minus 0.7579. I got 0.7595. Okay, my value. Okay, 95. Okay, and intercept I got it as 4.2578. More or less, it doesn't matter. Okay, so these are the values. Of course, you have to calculate so as to be able to. Okay, you have to calculate so as to be able to get the values of the linear regression. Okay, now what is it we will do? We have, of course, to find n. Okay, so this is the slope, right? Okay, your slope is equal to this, right? Okay, so we'll write it. Okay, 1 minus n. Okay, 1 minus slope equal to 1 minus n. It is equal to minus 0.7595, and n will be equal to 1 plus 0.7595, which is almost equal to 1.76. Okay, so this is your n. Okay, the question is asking me also to calculate the value of the k. So how to calculate k? From the intercept. This is the intercept. Okay, so we'll take it here. Okay, and we are going to use it here. Okay, so this is the intercept. It is equal to what? The value is equal to 4.2578. Okay, I need actually to find this here alone. Okay, so this is equal to what? This is equal to, okay, it should be equal to what now? Okay, it should be equal to what? Yes, it is equal to what? So it is equal to 10, okay, it is equal to 10 into to the power of 4.2578. Okay, now we have the value of n, value of t, value of n, almost, as we said, value of n is almost 1.76. The value of T is given 1030 Kelvin. Okay, now we want to find the units of value of K, and we want to have units of liters, moles, and what? Minutes. Okay, now you are noticing the time is given in second. Time is second. So we need to convert. So we'll get second, units of second in our rate constant. So we'll have to convert second to minute. But now the pressure PA naught is given in millimeter of mercury. So I need to have a value of R, which has units of what? Liters, moles, Kelvin, and millimeter of mercury. Okay, so as to get the units of K later on, as to get units of liters and moles as units of K later on. So the units of R, the R will be 62.36. Okay, so the R will be, okay, R will be 62.36. It will be liter atmosphere, liter millimeter mercury per mole, okay, per mole Kelvin. Okay, so this is our R. So what to do with this R? We substitute. I'm not going to do anything unless you do, unless you do. Otherwise, I will just give you, I will just say calculate, and that's it. Okay, because I'm not going to give any answers here. Okay, so this is going to be, okay, you substitute and you calculate. So you have to calculate to substitute for the in here, for the in here, okay? You have to substitute for the in, you have to substitute for R and for the T, all these. Substitute and calculate, of course, okay? And of course, if you don't show any calculated values, I'll consider that you use solver, okay? That's it. Okay, so this is what you have. You have to substitute and you have to calculate. Get the value of K. When you get the value of K, of course, you have to find you have to meet the units. Okay, value and units. Okay, so value and units. And the units, of course, will have, in them, you will have, okay, you will have second, 1/2, so other units, of course, second, minute, and convert to, right, okay? But you should have the other units also, right? That is the question of, in terms of the pressure. We have another question, which is, okay, another question, which is this question. You could see that. This question is for liquid phase, you could see that it is liquid phase, right? Okay, and liquid phase means it is constant volume, right? Okay, we also have one reactant only, A to R. The temperature here is 50. We will assume it is constant. We have values of C A naught and values of T hat, T1 over 5. So it is not T half, it is T1 over 5. So it's C A naught and T over 5. Okay, we want to derive all the equations, and we want to find the order of reaction and the rate constant. Okay, so this is the question, right? Okay, so this is your question. Okay, so now how to start? As we did previously, we have only one reactant, so it should be minus RA. Of course, we have to comment it is liquid phase. Okay, so liquid phase, so it means it is, okay, constant volume. Okay, and we'll assume constant T, assume constant T at, of course, it's given at 50 degrees C. Okay, you will start by writing minus RA equal to minus 1 over V, D in A by dt. And of course, it is equal to K1 reactant, Ca to the power of N. Okay, you are going to derive all necessary equations, show all derivation steps. And of course, you will have to show me that you have to give find CA1 minus N minus CA01 minus N over N minus 1, and you have it as K times T. Of course, then you are going to include the given time. Time is 1 over 5. It is at what? It is at CA equal to CA0 over 5. Okay, so you are going to substitute now for T half, sorry, T1 over 5, and you remove this CA. Okay, you remove it, replace it by CA0 over 5, and remove this T, replace it by T1 over 5. Okay, so this is your equation, and your equation now must be modified. Okay, so that should be 1 over 5 here. Okay, and that should be here. Okay, this should be. Okay, I'm not going to do the derivation as you are aware. I'm just pointing out to what you have to do. Okay, so as to solve. Okay, so this is your equation. Okay, and okay. Okay, so this is it. Okay, now what else you have to do? This is, as I said, these are all the steps. This is what we have here: 1 over 5, and this is 1 over 5, and this is 5. This is 5. Okay, everything that we did previously is it is the same, but it's only 5 here. Okay, 5. Okay, so this is what your equation. I have given the equation in the slides. But instead of giving it here, saying what? Saying this here, see here, instead of saying 1 over 5, 1 minus n, I said it is 5 n minus 1, which is the same equation. Okay, so it is the same equation. Anyway, so what is it we have? We have the equation now. Okay, what is it we will do? We have to calculate, of course. Okay, how to calculate? We have CA0, we have T half. We must calculate log CA0, okay, and log T1 over 5. Of course, then we are going to do linear regression. Okay, so you have only 4 values. If you are interested in calculating, right? Okay, if you are interested in calculating, we can do it. Otherwise, I'll just give you the final answers. Okay, so choose what you want to do. Choose what you think is useful for you. Okay, choose what you think is the best for you later on. Okay, and again, I'm addressing those who missed the test. If you think missing the test is going to give you more time, yes, it will be giving you more time, but it will not be giving you more grades. You will never get more grades if you miss a test. Never, ever. Didn't happen before, will never happen again. Okay? Never happened before. Any student who misses my test never gets more or better marks than those who attended the first test for the first time. Will never have a better chance than those students who did it for the first time. Okay, so I'm getting what answers for here. I'm getting answers, okay, for the linear regression. Okay, so I have R squared here. Okay, let me just check my answers here. Okay. Okay. R was giving me the answer. She said 0.999. Okay. Right. Okay. Slope is equal to what? Equal to minus 0.45. Okay. And 78. And we have the intercept is equal to 1.6808. Okay. So these are the values. Now, of course, according to our equation, slope, it is equal to 1 minus n equal to minus 0.4578. So n is equal to 1.4578. This is the n. Okay. Now what else? Of course, according to our equation, this is going to be equal to the intercept. Okay. So this is the intercept. So what is the intercept equal to from our linear regression? It is equal to 1.6808. Okay, and I'll be able to get what? I'll be able to get this here. This is what we have. Okay, and of course this equal to 10 to a power of 16808. Okay, and now of course we will substitute for the n. Okay, let's say يعني n for the sake of this class يعني 1.46 for example, and you will substitute. Okay, substitute for the n, you will be able to get the k, but you have to show all derivation or calculation steps. Okay, otherwise I will consider that you use solver. Okay, k, of course the k will have units now, but depending on the order. Okay, must give value, okay, and units, okay, of k, value and units of k. You must calculate and give the units. Okay, so this is regarding the question of the fractional life. Okay, so now we have to go and look at the question, which is in, we have actually several questions here that are simple questions. Okay, but I will okay, see these questions. Okay, which is about the half-life in the book, right? Okay, you have of course the answers, final answers. You have here a question. You have the half-life. Okay, sorry. Okay, so the half-life here of substance in the presence of enzyme, whatever, was found to be 221 seconds. It means we are giving the half-life. So you have the half-life. Okay, it is given, it is equal to 221 seconds, right? Okay, how long? Find the time. So time, okay, it will take for the concentration of the pyruvic acid to fall to 1/64 of essential value in this first order reaction. So we are told that this reaction is what? First order. So it's important, right? Okay, let me just copy this, okay, and use it. Okay, so it's important that we what? We know that the reaction is it is first order. Okay, so let's see here. This is what I have. Okay, sorry. Okay. Okay. So let's now look at it. So what is it we have here in this question? As we said, the question said it is what? First order. That is first order. First order, of course, we have what some relations that are specific for first order reactions. Since I am talking about the half-life, so since I was talking about half-life, it's given, okay, which is equal to 221 seconds, right? Okay, it is given. So, and I know it is what? First order reaction. Okay, first order reaction is given. This is given, right? Okay, given. okay, first order. So I can apply the relations. What relations? I know that, for example, T half is equal to 0.693 over K first order reaction. Okay, but of course you have to derive the equation. And I know also another relation, that is what? Final concentration divided by initial concentration. Okay, this relation is also for first order reaction 1 over 2. Okay, it is to a power of n, and n, it is the half-life period. Half-life, okay, period. Okay, so this is what we have. Yani these are relationships which are specific for first order reactions. You cannot use them for other orders. So what is it I want to calculate? It says that the concentration has what? It says that the concentration has, okay, dropped, okay, from 1 over 64 of its initial value. So the concentration has dropped by 1 over 64. 1 over 64. So what is this 1 over 64? Actually, it is this value. Okay, so it is given final concentration over initial concentration is equal to 1 over 64. It's given. Okay, so since it is given, I will be able to use it to find what? To find the n. So I can use it to find the n. So I can say now, this is what I know, and I'll be able to get the n. Of course, to get the n, you have to take what? Logarithms. Okay, so len, okay, 1 over 64, it is equal to n len 1 over 2. We'll be able to find the value of n, right? Okay, so if you are interested in finding the value of n and getting the answer, yes, okay, so it is equal to 6. So it is equal to 6. Fine. Okay. So then what do we do with this n? We will have to, we got the n. So we want the total time. Time will be equal to what? Time will be equal to n times the half-life period. Half-life period. Again, this is only applicable for first order reactions. So I have 6 and I have 2, 2, 1. It will be giving me the answer. Okay, it will be, of course, this is seconds, right? Okay, so this is one question. Okay, let's go and look at the other question. Okay, what is the other question? It is also another simple question. Okay, so let's see here. Okay, okay, so let's go to so another page. Okay, so this is what I have now. Okay, and I want to solve it. Okay, so let's try to solve this question. So it says the half-life of a first order reaction. Again, I'm talking about a first order reaction. Okay, is given. It is equal to that. What is the time constant? Okay, so we have what? We have the half-life. So T half, it is equal to 439 seconds. And it is what? First order. First order. So it is important, right? Okay. Now I want tau. Tau is equal to what? 1 over k. This is only what? Also what? Okay, this is only what? First order reaction. Okay, first order reaction. So this tau is also for first order reaction. So tau equals 1 over k. But I don't have k. But I have a relation. We just have written this relation, right? Okay, which is what? For first order reactions. Sorry. For first order reactions, we already know that, okay, K T half is equal to 0.693. So I will be able to calculate K. So K will be equal to what? K will be equal to 0.693 divided by 439. Okay, it will be giving me the K. When I know the K, I can calculate tau, which is equal to 1 over K. Right? Okay, so this is easy. But it has to be what? You have to know that the reaction is what? First order. So it's only applicable the relation that I have written here for first order, okay, reactions, okay, only, right? Okay, so you cannot apply it for other orders, right? Okay, so it's only for first order reactions only. This relation, okay, this is only for first order, right? Okay, so be aware that it's only for first order reactions. Fine. Okay, now what else we have? We have another question. Okay, let's look at the okay, what is the other question here? This is 1032. Okay, and okay, okay, So let's look at this question. Okay, the question here. Okay, what does it say? It says, okay, we have, okay, Arrhenius parameters for the reaction. We have a reaction. Let's look, let's see the reaction here. What is the reaction? This is our reaction, sorry. So this is our reaction, okay? Okay, so we have information. It says log, see here the information, log A, okay, equal to that. Okay, so what does it mean? It says log A, right, or log A, and the A, it is in second inverse. Yani we are given the value. We are told that the value of the units of A are second inverse. The units of A are second inverse. It is equal to 15.6. Okay, so, and we have EA, which is equal to 261 kilojoule per mole. It's given here. See here, EA is given that. What is the half-life? So I want to calculate T1 over 2. Okay, so what is it? Okay, at what? At 20 degrees C, okay, and at 500 degrees C. Okay, so how do we calculate? First of all, we have only A, okay, it is equal to 15.6. So what do I do with this A? I have the activation energy. What do I do with the activation energy? Okay, so it means it looks like I need to write the Arrhenius because I have A, I have EA. I can write what? K equal to what? K equal to A, E minus E over R T, right? Okay, okay. So what do I want to calculate? I want to calculate T half. Okay, so how do I calculate it? I don't have table. I cannot plot. I cannot find the. I don't know. Yani, what is the idea here? What do you think? What is the idea here? I want to calculate the T half at what? At two different temperatures, right? Okay. So what to do? What information do I have about this reaction? Okay. Find K using the Arrhenius parameters. Okay. Then what do I do with the K? If I find the K, what do I do with the K? So I will find the K at what? K at 20 degrees C, okay, and K at, okay, 500 degrees C. Okay, so if we find the K, then what is it we will do with the K? So we have the, we don't have the A, we have, because we have the units. Units of what? Assume elementary, we have the units of A. So units of A, okay, so what? So what does it mean if I have the units of A? What does it mean? A follows K. Okay, so units of A are second inverse. Units of K will be what? Units of K will be, yes, units of K will be what? Second inverse. So what does it mean? Units of A second inverse. So units of K will be second inverse. So what does it mean? Okay, so what does it mean? Any information here? Okay, okay, what does it mean? Okay, then units of K. Okay, so I concluded that units of K are second inverse. So what? So what? Anything? Any conclusion here from that? Yeah. Okay. Okay. So I cannot do more. Here I have log A. It is equal to 15.6. I'll find A, which is equal to 10 to the 15.6. It should be second inverse. Okay, so we'll put it here. Okay, 10 to the 15.6. Okay, E minus 261, 10 to the 3. We divide by, this should be joule per mole. Okay, you divide by 8.314 joule per mole Kelvin. Okay, and you multiply by 20 plus 273.15. Okay, so anything regarding here? Okay, what my question? I'm asking you. So what does it mean if K is having units of second inverse? What does it mean? Okay, what does it mean? Okay, and also I'm asking you, what does it mean if K is having units of second inverse? What does it mean? So it is first order. Yes, excellent. Okay, so I'll just copy that and okay. So that should be for K. Okay, so that should be here. Okay, so we have, since, so it means it is what? So that should be now, okay, 500, right? Okay, it should be 500. Okay, so since we know, okay, okay, so second inverse, then it is what? Then the reaction is what? Reaction is, okay, first order. Okay, so let me just write it, okay, somewhere. Okay, okay, so, okay, this is what we have. Okay, so we'll just put it there and we will comment. Okay, so we said units of K is going to be, okay, second inverse. Okay, then, okay, it is what? Then the reaction is first order. Okay, reaction is first order. So what do? We can apply the relations of the first order reaction. What relations? This relation, we can apply it, right? Okay, so this relation. Okay, so we'll apply it twice. Okay, we'll apply it twice. We'll apply it at what? At, okay, at 20 degrees C. Okay, okay, we'll apply it at 20 degrees C, okay, and we will apply it also at, okay, we will apply it also at 500, okay, but we have, of course, to calculate the K at, okay, so it should be at what? At 500 degrees C, right? Okay, but we have to calculate, this is at 20 degrees C, and this is at what? 500 degrees C. It means you have to go and calculate the values of K's, the K's, okay, at 200, 220, and 500, these values, right? You have to calculate them, okay, and you have to get the answers, and then you substitute, okay, and that will be giving you the answers, okay. Fine, so these are the answers that you have for A and for B. Okay, so this is what we have for the these two questions, or the questions that we from the book questions, right? Okay, and I think we are done with the questions of the book. Okay, we don't have any more. Okay, and I will go, and we don't have time actually to finish the solution of this question, but at least we are starting. See here the question. This is for the parallel reactions. Okay, this example. Okay, this is for parallel reactions. So what do we have to do? We want actually to calculate. Okay, we want to calculate the rate constants K1 and K2. So we want to calculate the rate constants K1 and K2. As you are aware, for the parallel reactions, we cannot, we have to derive more than one rate equation. We have to write more than one rate equation, and we have to derive more than one rate integrated rate equation. Yani we have to do, if I have here, so you could see I have two constants, right? Okay, so two constants, K1 and K2. Then I will need to write, it's not enough to write one rate equation. Okay. Now, how many reactants we have? We have only one reactant, A, but appearing in two reactions. Okay, but I have products. I have three products. Okay, I have B. Okay, and I have, so I have B, I have E, and I have D. You could see that it is in reactions number 1. Okay, reaction 1 and 2. Okay, B, it is in reaction 1 only. Okay, DE, it is reaction 1 and 2, and you have D, it is in reaction 2 only. Okay, so this is what we have. Okay, we have different, the species are appearing in the reactions according to according to the this order. And 1A in 2 reactions, D in 1 reaction, okay, B in 1 reaction, E in 2 reactions. Okay, so now we have to use the these يعني we have to write the equations, and usually I start by writing the rate equation for A, and then we decide where to go. Thank you.